Now moving to the next question, just see. Next question. A galvanometer having a coil of resistance 100 ohm gives a full scale deflection of 1 ampere current is passing through it. What is the value of resistance which can convert this galvanometer into a voltmeter giving full scale deflection for a potential difference of 10 volt? Now see this. Here in this question, like this is a galvanometer and resistance of galvanometer is given Rg. For full scale deflection, how much current should be passing through galvanometer? Ig. Ig is the current passes through the galvanometer for full scale deflection. This is for full scale deflection. Then I just want to convert this galvanometer into voltmeter. Then I will connect one high resistance in series with galvanometer. Clear? Now this will become my voltmeter. So in this question they have mentioned what is Ig. Ig is what? Ig is how much? 1 milliamperes. Ig is 1 milliampere. Clear? So 1 milliampere will be 10 to the power minus 3 ampere. Is it clear? Now for full what is the coil resistance? Resistance simply 100 ohm. So 100 ohm is how much? Rg is 100 ohm. Now they are asking what should be the value of this R so that I can able to measure a potential difference of 10 volt. So simply this is voltmeter. Now this is voltmeter. So when you fix this voltmeter across, for example in this circuit some current is passing, some voltage drop, then you will apply this voltmeter like this and you are able to easily measure the voltage. Now they are asking what should be the value of R I must add in series with galvanometer so that how much voltage it is capable to measure? 10 volt. So simply formula is V is equal to Ig R plus Rg. Clear? So this is given how much? 10 volt. Ig is 10 to the power minus 3 milliampere. Now how much R? We want to calculate this. Rg is how much? 100 ohm. Clear? Now this is 10 to the power 3. It will be here R plus 100. 10 to the power means this is how much? 100. Can I say? So what should be the value of R? R comes out to be 9.9 kilo ohm. This is the answer. Here. So right answer is 9.9 kilo ohm. Moving to the next question. The balancing length for a cell is 560 centimeter in a potentiometer experiment when an external resistance of 10 ohm is connected in parallel to the cell. The balancing length changed by 60 centimeter if the internal resistance of the cell is n by 10 where n is an integer. The value of n is how much? So simply the balancing length for a cell is how much? L is 560 centimeter when an external resistor of 10 ohm is connected. So when switch is closed, then finally you are getting L dash is how much change? Change by 60 centimeter means now L dash is 500 centimeter. So we know the relation of, we already calculated this relation and I hope everyone know this. R is equal to capital R L1 by L2 minus 1. So what is R? How much? External resistance. External resistance is how much? Is it given? Internal resistance is n by 10. Clear? Internal resistance is n by 10. External resistance is 10 ohm. So this is n by 10. And how much R? R is 10. Clear? Now L1 is how much? When there is no external resistance added to the circuit. Now when you add any external resistance in parallel to the cell, when you add any external resistance parallel to the cell whose EMF we want to measure, that is L2. Then how much L2? 500 minus 1. Clear? So how much N? They are asking 100 into 560 minus 500 will be 60 by 500, and finally you are getting the value is how much? 5 1s are 5, 5 2s are 10. So N will be how much? 12. This is what they are asking. Clear? Now see next question. 4 resistance 15 ohm, 12 ohm, 4 ohm, 10 ohm are respectively in a cyclic order to form a Wheatstone bridge. Now the resistance that is to be connected in parallel. So simply how to draw the Wheatstone bridge? 15 12 4 10. Remember 15 12 4 10. 15 15 12. Now that is 4 and this is I think 10. Clear? 4 10 15 12 4 10. Cyclic order is 15 12 4 10. Now they are asking the how much resistance that is to be connected in parallel with the resistance of 10 ohm to balance the network. So what is the condition of Wheatstone bridges? Ratio of adjacent resistance. For example 15 by 12. This ratio must be equal to the 10 by 4, but here it is not equal. So they are asking what should be the resistance must be in parallel with 10 ohms so that our bridge balance. Now finally when you add this, so you are getting what? 15 12 and this is 10 12 in parallel is 10 into 2 r 10 plus r, this is 4. Now they already mentioned like when you add any resistance in parallel with this 10 ohm then bridge is balanced. So finally you are getting this bridge is balanced. Now we will apply 15 by 12. Clear? 10 r by 10 plus r divided by 4. So simply you just need to apply the calculation. So 3 5s are 15, 3 4s are 12, and finally you will get the answer. So I hope you can easily solve the value of this r. It's very easy calculation. Now moving to the next question. 4 resistance 40 ohm, 60 ohm, 90 ohm and 110 ohm makes the arm of quadrilateral ABCD. Can you see quadrilateral ABCD? Across AC is a battery of EMF how much? 60 volt. How much? 40, sorry. 40 volt. And internal resistance is negligible. The potential difference across BD. Across BD they are asking the potential difference. So very easy question. Now tell me, here it is 40 volt, then across from A to C. From A to C, how much is the voltage drop? Across the AC is 40 volt. Clear? Now tell me, apply the formula and tell me how much current is passing through this. I1 and I2. How much? Simply 40 volt equal I1 multiply simply 60 into 40, 100. I1 will be how much? 2 2s are 4 by 10 means 0.4 ampere. Clear? So we got the value of I1. Now tell me how much will be the I2. I2 is simply 40 by 110, it is 200. So 4 5s are 20. Finally how much I2? 0.2 ampere. Now they are asking the potential difference across BD. Simply we will apply the Kirchhoff's. It will be how much? See here, VA from A to B. VA, just take the potential at A is VA minus it is 40 into I1. 40 into I1. Then this much is left at B. This much money you have, this much you have spent. Then how much it is left? VV. Clear equation first. Similarly apply the Kirchhoff from A to D. So VA minus 90 into I2, then this much is left at D. Now they are asking VB minus VD. So very simple, minus plus minus. This cancel out, 90 I2. Finally we are getting how much? Plus 90 I2. Now I2 is how much? I2 is 0.2 and I1 is 0.4. I2 is 0.2 and I1 is 0.4. Clear? So VB minus VD, they are asking VB minus VD. So just this calculation only you can easily solve. I think this will be 18 and this is 16. 18 minus 16 is 2 volt. So finally the answer is 2 volt. Clear? Now go to the next question. In the figure shown, the current in the 10 volt battery is close to. Simply you need to apply either Kirchhoff's law in this circuit. I hope just apply Kirchhoff's law, or you can apply different. This is a homework. Like this question is homework for everyone. Try this at your home. Now moving to the next question. In this question, in the circuit given in the figure, current in different branch and value of one resistor are shown. The potential at point B with respect to the point A. So what should be the potential at B with respect to the point A? They are asking VB minus VA. So assume at A potential to be 0 volt. Assume, because they are asking with respect to the A. Now moving from, if this is tell me, if this is 1 ampere, this is 1 ampere, this is 2 ampere, then there should be 1 ampere. So I will move from A to C, then C to D, then D to B. A to C, then C to D, then finally D to B. This is my path. From A to C, C. From A to C, how much voltage gain? 1 volt. At A potential is 0, then it is gaining how much voltage? 1 volt. Now we are moving to the C point. C to D, how much voltage gain? 2 into 1 plus 2. From D to D minus 2. Then this much is left. This much energy you are having initially. Finally you are gaining, again losing. Then how much is left at B? Simply 1 volt. 1 volt is the answer. Plus 1 volt. Clear? Moving to the next question. In a meter bridge experiment, S is the standard resistance, R is the resistance wire. Clear? So meter bridge condition is simply very easy question. R by S, and this is L by 100 minus L, because if this is L, total length is 100, because it is a meter bridge. Clear? So it will be 100 minus L. 100 centimeter. So this length is L, then this much is, this length is L, this much is 100 minus L. So in the initially they are saying like the balancing length is 25. So L is 25, 100 minus 25 is 75. So R by S is 1 by 3. This is equation number 1. Now if R is replaced by a wire of having half length and half dia. So what is the formula of resistance? Very easy question. R is equal to rho L by 2 and area rho L by A. Area is pi R square. So when pi R means, can I say D square by 4? R is D by 2. Now they are saying half dia. Half dia means how much? This is half. So finally you will get the value of this R. R dash. R dash is how much? Rho L by 2. And this is area is pi R square. R square means R is D by 2. D square by 4. And dia they are saying as per the question half dia. Half dia means this is also 1 by 4. Like this. So this is 2 to the 4. Comes out to be above. Clear? So it will be R dash is what? Twice of R. So finally we are getting, again you will apply the formula. What is the formula? R dash by S. R dash by S. And now L dash by 100 minus L dash. You know this. You know they are asking L dash. Clear? Simply you can apply to R by S. R by S you already know. L dash by 100 minus L dash, they want L dash. So simply you can easily solve. R by S you will get from the previous equation. So it's a very easy question now. So once again, thank you so much. Make a habit of solving by your own. So thank you so much. Thanks a lot.